Hello everyone, welcome again in this new video which will be about microcontroller KB9022 flash-in programming using RT809. So this microcontroller in fact was soldered there twice, once by a nearby shop, but they didn't managed to make it aligned, and as they don't have any programmer that can program this one, so they bring it here and ask me to do the whole job. So I have to remove it and then resolder it again, which was in fact a little bit hard because it's used, so they didn't use a new one. They have using this one, which is a used one, and it looks like this. Let me show you how it looks when they first bring it here. Let me find. I have taken, in fact, a photo of that using my scope. Let me find that. Give me just 1 second. Where is that photo? Where is that photo? Okay, let me find it. Just be patient. So it's on desktop. Yes, I found it. Okay, open it. Yes, and here it is. So it's this one. As you can see here, when I got it, it was like this. So even though it was aligned perfectly on this side and a little bit there in this on the bottom, but on the left side and on the top side there was a miss. So I was obliged to take it off again and redo the job from the beginning. So as it's not new, it was a bit harder to work with this, to solder this one. But in fact, it takes me 30 to 40 minutes to make it like what you see right here. And in fact, this one, I have done a small clip about it, and let me fetch it. And it was posted or uploaded to my channel. It's this one. Let me show you. Yes, it's this one. And I'm sorry I wasn't commenting on this video, as I was following the Rapid Chess or Championship on chess.com. But in fact, it doesn't need any comment. In fact, what I did in this video is clear, and anybody can understand. The only thing that I have to explain is toward the end there. So here, as you can see, these lines, these pins are a little bit needs a little bit alignment. So they need to be pushed toward the right. So push from the. So I use, when I got this issue with the microcontroller in one side, if it was with one side only, so you can try your trick, which I tried there, and it works. So you just use, as you can see here, where my mouse is pointing, it's tweezer. With the hand of the tweezer, I use it to push the microcontroller from the left towards the right while I'm using my soldering iron, my very hot soldering iron on the pins, going back and forth quickly so that the soldering melt and the microcontroller will move toward slightly, will move just slightly what's needed. It just needs to be slightly moved toward the right, and it's very beautiful trick that you can use when dealing with microcontrollers. So you have to be quick with your hot air, which should be very hot, and at the same time pushing with something, but pay attention to not to destroy the pins here where you're pushing. So usually I'm using the tweezer, this one, tweezer, and I put it here over or here above the pins, and I push the microcontroller while using soldering iron on the pins. So I say the soldering iron should be a very hot one and a good soldering iron. That's it. So after the job is done, let's check what we have as a result in terms of the behavior of the board. Just to check that we won't get any display with this board, even if it works, which I hoped, because the microcontroller needs to be programmed. It's KB9022Q, which is a programmable chip. So, sorry. So let's apply power if and I have already verified if no short on the board, especially in the main power rails. So don't apply power just after soldering the microcontroller without verifying the board, especially the main power rails. So let's touch the cable. Let's power the power supply. You don't see it. Here it is. So as this on each page should be 19.9. Yes. And let's push the on button. So we got this lid, which is a good sign. And here we have, I got the board like this without heatsink, only the DC jack and the power button with the board. I have forgotten to ask the guy who brings this to bring the heatsink. I will need it in fact, but anyway, let's do. Sorry. So I'm pushing the power button. Let's do the programming of the microcontroller first, and then I will send for heatsink. It's not far from here. It's a nearby shop, so it's not an issue in fact. So as you can see in front of you, it's dropping only 0.1, which is not sufficient. Not sufficient for this board to display. And let me power the meter and connect it to the in the PC. Okay, you don't this. Here it is. Let's connect. Let's check what do we have as voltages. So probably let's check the battery connector. We have 3 volt air, then that's fine. We have 3 volt on the battery connector. Is good. Okay, here. Okay, the 5 volt, the 3 volt. Let's check these ones here. So this one. Okay. So these are irrelevant in fact, except 3 and 5 volt which are present, and that's good. So let us now program this microcontroller. So we need to solder wires to the keyboard connector, because we are going to use the RT809H programmer. This one. Let's fire the software. So we need to program the KB9022. So KB9022, and I usually choose this one. I see this one. So this one. Yeah. Up. Okay. And we have the description of how to connect the wires to the board. So it's easy to understand. So this here is the programmer, and these wires, these lines points out to the wires that we need to use, and they shouldn't exceed 10 centimeters. And the number here of the pins are the number of the pins on the microcontroller. So as you can see here, KB90XX, meaning the KB90 series. So let's solder wires. So how to do that? We need, in fact, as you can see here, this gives us the pins number of the microcontroller, but we need to find the corresponding pins on the keyboard connector, because we have to use the we have to use the keyboard connector. Program this controller. Let's power off this chip It's a little bit warm, that's normal because the board is dropping some power. So what now? The wires. So I already have this adapter which I use with my RT, and already have the wires, and already have the pin number of the microcontroller. So each wire corresponds to a pin 60, 61, 59, 62, and 42, and it's what we have in here. 60, 61, 62, 90, 59, and 42. That's what we have here in the description of how to wire this microcontroller when trying to program it with the RT809. So how to locate the corresponding pins? That's easy. In fact, it's if schematic is available, that's an easy task. If the schematic is not available, so you can use a similar schematic of a board, or sorry, you can use a schematic of a board which has this, similar. It should be HP, of course, and it should have the same microcontroller, and it should have the same keyboard connector. If it's 32 pins, it should be 32 pins. If it's 28, it should be 28 on the schematic. And of course, you can use it to locate your pins on the keyboard. So let me check where I have the schematic. I think I have it somewhere. Let me check. So sorry about that. Yes, I found it. So here it is. Let me show you. Sorry. So we have our schematic. This one. And now we need to find the corresponding pins. Pin 60, the microcontroller, we need to find where it goes. Pin 61 and the other pins. How to do that? It's just simple. So let's search for 9022, hit enter. So you got the result. You zoom, close here, and you search for pin 60 here. So they should be on this side, and they should be here within this area. So don't waste your time. Should be there. Your wiring should be here. So pin number 60, for example, pin number 60. So as you can see here, you follow the line, and we have a KSI4. here. Remember it, or you just write it down on a paper and search for it. ASI4. Enter. So you scroll on the search result until you get in the keyboard connector, this one, and the corresponding pin on the keyboard here is, as you can see here, it's a 32 pins connector, and it's exactly what we have on the board. So the pin number 28 corresponds to pin number 60 on the microcontroller, and you do the same thing for the other pins. So you do the same thing until you find all the pins, corresponding pins, and write them on a paper or whatever you want, and then do your solderings, do your wire solderings. Me, I'm using this adapter which is already have the wires. So I'm going to solder my wires and see you in a while. I'm going to pause the video right now. I don't want it to be a big video, and we will see after how to use the programmer. I just recall thing that you can use to quickly locate your corresponding pins on the keyboard connector. If you are a user of SVOD and you have the software for that, you just launch the SVOD programmer software. You go to setup and edit the choose any here, any which is the brand of the microcontroller. You go to setup, edit the motherboard. You just click on edit the motherboard, and here you can see here you have here the let me make it visible for you here. So here you have the pin out of your microcontroller, and you have the pin 42 here. It's for the it's the number of the pin on the microcontroller, and here it's corresponding signal on the keyboard connector, which you need to tape on the source of your schematic to get the exact pin number on the keyboard connector. So it may differ from board to board depending on the number of pins that your keyboard connector on the board has. So it's easy, in fact. And if there's a board view, it's easy to locate these things. You just type KS03, for example, and you quickly get the, or you just go to search for the keyboard connector on the keyboard connector on your board view, and you keep clicking on the pins one by one, and the names will show on the left side of your board viewer, or if you're using another software to view the board view, you will you probably know where to see. That's it, and see you in a while. I'm going to solder my wires now and then come back to program to read and erase and program our microcontroller. Here we are. So we have the wires. So easy. You have your keyboard connector. You have if you have this, let's say from SVOD software, you put it here aside, just like this. It up, edit here, and you make your connections easy. Pin 42 to KS03, which is somewhere here. There, this one. Number 15 on the keyboard, etc. And in fact, you're referring to this diagram, which is on the RT programmer software. So I have my connections. I have my programmer here. I have to pay attention because the wires don't want to pull out any wire. Takes some time to solder them because we have here connector for SSD, which is next the keyboard connector, and it was a little bit tough to solder the wires here. So you have to check all the nearby wires if they are not connected together. Like for example here I have the yellow is next to the yellow next to the red. No connection. And next to the red there's green. No connection. And next to green there's gray. And the blue wire is far from all of them. I have this crocodile connector which I soldered to the ground of this USB cable, which I'm going to use with my programmer. So I have to fix the ground somewhere on the board, and before pluging the programmer we go to our software here. Again, let's clear all this, delete again. So now let's check if we can read. So we have to power the board. So let me show. We have to power the board, and just after that you push the read button on the software. So let's power our power supply. So before pushing on the power supply, be ready to plug it should be visible to plug the USB connector on the programmer, then push the read button on your programmer. So we put the mouse ready on red. We make our program. We power our power supply, and immediately push the USB cable, and then push red. Again, let's do it again. Let's power off power supply on read. Okay, let's put on wire here. Let's temporarily name it KB9022, and the name of the guy bring in the board. Save. So again, so we keep the USB cable plugged on our programmer, and then we just power off the power supply. Now it's outputting nothing, and back to our let me add a scene here so that you can see that clearly. So let me add you scene. I don't know if I can do that, or source. I don't know if I can do that while I'm recording. So yes, Windows capture. Let's RT. Okay, and yes. Okay, so here we have. That's really a file. Cool. It here. How the what is important is the what we're doing. So doesn't matter if it's not well recorded. What is important is the content. So our power supply is off. Yes, is on the position off, because we have off and on button on Discord, and it's now it's on, but it doesn't output anything. We have to push the on button, and at the same time click on read. Let me fix. I don't see the cursor on that one. Now you can see that it's highlighted as I move the cursor on the mouse on the button. So I am on read now, and as far as I power, I click read. That's good. Power off the power supply, and let's save. In the same location, let's open. We have it there. It's just compared to see, we don't need this original one as it's from maybe other board as they have used one. So we just have to check if the reading is correct. So analyze data comparison, compare. Cool. That's fine. So another reading, why not? Ah, you don't see what I've done. So I have opened the location where I have saved my files and selected them both, hit enter to open with the HXD editor or any other editor if you use a different one, and you compare the files. They are different. That's fine. And let's go back to our programmer software. There. Again, let's put the mouse cursor on the read button and pay attention to the power supply on the screen. I am going to hit on and at the same time read. Not at the same time, just 2 seconds after or 2 seconds after. Don't be late. So on, read. Now change the name to B to triple B, just to, as I said, to see if the reading is exact. Analyze, data compare. Okay, that's fine. So now I need to search for the file for this board. Just give me a minute. So where I put serum here. Let's move it to the same location where I have just saved. Okay, let me open. You don't see, I know. Just be patient. I'm just looking for the firmware to use and to check the size. Yes. Okay. So we have it there. This one, serum, and open. Let's see if the guy is telling the truth and if micro the microcontroller is from another board or not. Oh. Maybe it's from another similar board. I don't know for that, but it looks like there's some. Let's analyze them. Oh yeah, they should be different in fact, but the header looks like similar in both files. Yes, and for the, let's go to to the last data. Let's copy. Let's check again in this file. So find again, paste here. Okay, and now they are okay. So there's differences between the files, but what we need now is to program our microcontroller with the file we have here. This one. So serum, we go back to here, we go to our software, file, open, and desktop, and here is temporary, and there in this serum, select, and same thing, power off, power supply, on, and right. Just after pushing the on button on your power supply, you push down or you hit the read button on your software. Okay, let's wait. I don't know about the BIOS. So file has been saved. What do we have here? Start writing ship, elapsed time. Oh, okay, that's fine. Let's read it again and compare the file with the one we just used. So the power supply is off, on, read. Okay, let's put it next to the one that we have used right now and test or compare or call it whatever you want. Okay, we go back to the folder. We have our file which we have read right now. This one and this one, which we have used to program. Open both files and analyze, data compare, identical. Our microcontroller is successfully flashed. Now let's see what do we have as a result. Power off, remove this USB cable, don't remove the wires. You can keep the wires like this, nothing to worry about. Yes, so this is, don't forget to remove the power if you're using, because this programmer, it can be we can use extra or additional power in using an adapter of 12 volt. So if you're using that adapter, don't forget to remove it before before testing your board with the connection still on. Let's power supply 19 on and power button. As you can see, we have a result, and as I don't have the heatsink, so it's getting hot. Our processor is getting hot. Let's power off I don't have VGA. I can use, I have here the, so now you don't need this. Let's remove this window. So we got result. I may use the HDMI to test the display. Here I have RAM test with. Okay, and where's that HDMI cable? Okay, I need to how to test this. Okay, I don't know if it's possible without a keyboard. Yes, keyboard. Talking about keyboard, I'm going to simply test the check if the press of if the keyboard is responding on this board. So we have the RAM. In fact we shouldn't keep this board powered for a long time as we don't have the heatsink. Let's just see if I can get some response on my keyboard. Let's power. Okay. Not yet. So it's not that hot, not that very hot, but the keyboard is not. Take the not yet, no response on the keyboard. We got now. We have, see quickly. Yes, so power off. Fortunately it doesn't get very hot quickly, and it's already full. That's fine. We came to the end of this video, and I hope you learned something new. I already have done a video about how to program this kind of microcontrollers, but why not doing it again? Try if you're doing this from time to time. I would advise you, if you're doing repairing laptops as a job, I advise you to practice on dead boards. You have to practice on dead boards, how to solder wires on the keyboard, how to read the different microcontrollers, how to solder the microcontrollers on the board. It's not an easy thing to do, but with practice we just became perfect. So we need to practice. Why not 3 times or 4 times each week with the microcontroller? It doesn't matter if the board is a dead board. You just have to remove the microcontroller and try to solder it again. Check your solderings, check if the pins are all aligned, and so on. And after that you can practice on a good working board. Why not? Even if it with the display, you can just read the microcontroller, save the file, save it 4 or 5 times, compare the files. If they are identical, then erase your microcontroller on the board, erase it, power the plug the adapter or the power supply to your board. Check the behavior of your board with the microcontroller, with the blank microcontroller. You erase it using your software, program software, and don't program it. Just try to see the behavior of your board. So note that you have to take notes. Notes can be photos, writings, why not videos, or just your voice, recording your voice with your phone or something like that, and store that in your desktop, and you probably will need those notes in the future, because for example, personally, this same board, I have done this at least minimum, this board, this same board was on my bench table at least 500 times. So this board, because this HP model is got used there in Morocco, and it's the same thing in your country. Those laptops which are largely used, they will come to your shop for repairing. So take notes, you will need them. Don't try to remember that to record that in your memory. You can't hold all the your work just by memorizing that in your head. So you have to take notes. That's it. We came to the end of this video. I hope everybody's fine, and yeah, bye bye and take care, and see you in the next video. Bye bye.